The goal of this video is to briefly summarize our NIPS paper, Matching Neural Paths, Transfer from Recognition to Correspondence Search. Let's get started. The task is to find low-level per-part correspondences between objects. For example, you could consider matching image pixels or sound millisecond time steps. This is a complicated task because there might be multiple candidates for a correspondence. We illustrate matching image pixels at the bottom of this slide. At the top row, there is a patch from the left image which should be matched with a patch from the right image. There are two options for matching, middle and bottom. If you look at the appearance at the level of individual pixels, the two matching candidates are hard to distinguish. But as you increase the context, it becomes clear what is the right match. So this illustration gives us an idea how we could find low-level correspondences. To see if the center of the wheel matches, we could check one level up, if the wheel matches, and once again one level up, if the part of the car actually matches. Now, such a semantic representation would indeed be useful, but how to get it? Our idea is to use activations from a convolutional neural network. So how does our method work? First of all, we have two objects, the reference and the searched. You can see them at the bottom. And we want to find correspondences between them. We assume that objects are represented as grids and run the same convnet on both of them. Eventually we get a graph of activations. In this graph, the nodes are activations and the edges are computational dependencies in the convnet. Now assume we want to check if red nodes in the input layer match. For that, we consider all the paths which exit them, I denoted a few of them by red arrows, and we compare the corresponding activations on those paths. If they match, this supports a hypothesis that the red nodes match. In the paper, we propose a linear time algorithm to aggregate evidence over all such paths. Now we show some of our results. You see stereo matching error in those tables. The lower the better. Our method is shown in the rightmost column. It improves considerably over the baselines. Here are some qualitative results. In the first three rows you see normal image matching, and in the last, matching of style transferred images. We applied different style transfers to the reference and searched images. It is interesting to see that the quality does not drop that much because of that, which indicates the robustness of our method. We currently plan to apply our approach to sound and text correspondences. That's all. Thank you very much.